Good morning, everyone. I'm excited to welcome you to today's presentation. We're going to explore the fascinating world of computers with our topic, Understanding Computers. This is the first slide, so I just want to briefly mention that we'll cover the basics of what computers are, how they work, and why they are so important in our daily lives. I promise it will be an engaging and insightful session. So let's get started. Now, moving on to slide 2, let's explore the different types of computers. As you can imagine, computers come in various forms, each designed to serve specific needs. We have supercomputers, which are incredibly powerful and used for complex scientific calculations. Then there are mainframes, essential for large organizations handling vast amounts of data. Personal computers, or PCs, are what most of us use daily, from desktops to laptops. Additionally, there are smaller devices like tablets and smartphones that have become integral to our everyday lives. Understanding these different types helps us appreciate how versatile computers are and how they fit into different contexts and requirements. This diversity is a key part of the overall picture of computer technology that we'll be exploring today. So, what is a computer? Well, at its core, a computer is an electronic device that processes information. It takes data as input, performs operations on that data, and then produces output that we can use. Think of it as a very fast, very precise problem solver. Computers are everywhere, in our phones, in cars, in appliances, and of course in our workplaces and homes. They help us communicate, work, play, and even manage our daily routines. The key point to remember is that a computer isn't just a machine. It's a tool that helps us turn raw data into meaningful information. This connection to data processing is fundamental to understanding how computers fit into the broader world of technology. Throughout this presentation, we'll see how computers have evolved and how they form the backbone of so many modern innovations. A computer is truly one of the most brilliant inventions of mankind. Thanks to advances in computer technology, we've been able to store and process enormous amounts of data that would be impossible for us to handle manually. This means we can save our mental energy by relying on computers' memory capacities to store information efficiently. Computers significantly speed up our daily work, helping us perform tasks more quickly and effectively. They also play a crucial role in carrying out critical transactions, such as financial operations and important business activities, ensuring these processes are smooth and reliable. Moreover, computers help us achieve a high level of accuracy and precision in our work. They reduce the chances of human error, which is especially important in fields where mistakes can be costly. Overall, these capabilities highlight how integral computers have become in making our lives more efficient, accurate, and reliable, truly aligning with our goal of understanding their impact on modern society. Let's take a closer look at the different types of computers. As we discussed earlier, computers come in various forms, each designed for specific tasks and users. Starting with personal computers, or PCs, these are the most common and are used for everyday tasks like browsing the internet, working on documents, or gaming. They are versatile and accessible to most people. Next, we have laptops, which are portable versions of personal computers. Their main advantage is mobility. They allow us to work from virtually anywhere. Then, there are servers, which might not be as familiar, but they're essential for managing network resources, hosting websites, and handling large amounts of data. We also have supercomputers, which are incredibly powerful machines used for complex calculations, scientific simulations, and data analysis. These are typically found in research institutions and large organizations. Lastly, there are embedded systems. These are specialized computers embedded within other devices, like microwave ovens, cars, or medical equipment, performing specific functions reliably. Understanding these different types helps us see how computers are tailored to different needs, from everyday use to specialized tasks, and highlights the importance of choosing the right type for the right purpose in our technology-driven world. Let's take a closer look at the different types of computers based on how they operate. We have three main categories: analog, digital, and hybrid computers. Each of these types works on a different principle, which makes them suitable for various applications. Analog computers process continuous data, meaning they work with signals that are smooth and variable, like temperature or pressure readings. Digital computers, on the other hand, handle discrete data, which is represented in binary form, zeros and ones, and are the most common type we use today. Lastly, hybrid computers combine elements of both analog and digital systems, allowing them to perform complex tasks that require both continuous and discrete data processing. Understanding these distinctions helps us see how different computers are designed for specific purposes and how they fit into the broader landscape of technology. This classification is fundamental as we explore how computers have evolved and how they are applied in various fields. Today, let's talk about analog computers, which are almost extinct these days. Unlike digital computers that process data in discrete chunks, analog computers work with continuous signals. This means they can perform several mathematical operations at the same time, which is quite different from what we're used to with digital systems. They use continuous variables, think of them as smooth, flowing measurements, for their calculations. These variables are manipulated using mechanical or electrical energy, which allows for real-time processing of complex variables. Overall, analog computers played a significant role in the history of computing, but their limitations in flexibility and precision have led to their decline in favor of digital technology. Let's talk about digital computers. These machines use digital circuits, which means they operate based on two distinct states. Think of these states as bits, which are simply zeros and ones. You can imagine them like switches that are either on or off. This binary system is fundamental because all the data in digital computers is represented as a series of these zeros and ones. Now, why is this important? Because digital computers are particularly well suited for handling complex calculations and processing tasks quickly. Their ability to perform high-speed operations makes them the backbone of modern technology. Plus, they're programmable, meaning we can instruct them to perform a wide variety of tasks just by changing the software. Connecting this to the overall theme, understanding how digital computers work helps us appreciate their versatility and power in today's digital world. They form the core of most computing devices, enabling everything from simple calculations to advanced data processing. Now, let's take a closer look at hybrid computers. These are interesting because they combine the strengths of both digital and analog computers. Essentially, a hybrid computer uses both types of processing to handle different tasks efficiently. The digital parts are responsible for process control, and they do this by converting analog signals into digital signals. This conversion is crucial because digital processing is more precise and easier to manipulate for complex calculations. By integrating these two approaches, hybrid computers can effectively manage a wide range of applications, especially where continuous data needs to be processed alongside discrete data. This concept ties back to our overall theme of understanding how different computer types can be optimized for specific tasks, showing how hybrid systems offer a versatile solution in modern computing. Let's take a closer look at the classification of computers. As you can see, computers are categorized based on their size, power, and purpose. This classification helps us understand the different types of computers and how they fit into various applications. Starting with the smallest, we have microcomputers, which are what most of us use daily, like desktops, laptops, and tablets. These are designed for individual use and are very versatile. Next, there are mini-computers, which are a bit larger and more powerful, often used in small to medium-sized businesses for specific tasks. Then, we have mainframes, which are larger and capable of processing huge amounts of data simultaneously. Think of big organizations or banks that need to handle a lot of transactions at once. Finally, supercomputers are at the top of the scale. They're incredibly powerful machines used for complex scientific calculations, whether modeling and research that require immense processing speed. Recognizing these classifications helps us see how computers have evolved to meet different needs, from personal use to large-scale scientific research, all fitting into the broader theme of technological progression and specialization. Let's take a look at the classification of computers. As we explore different types, we'll see how they vary based on their sizes and functionalities. This classification helps us understand how computers are designed to meet specific needs, from small personal devices to massive data centers. It's important to recognize that each type plays a unique role in our daily lives and in various industries. Understanding these classifications also ties into the overall theme of how versatile and adaptable computer technology has become over time. So, as we go through this, keep in mind how each type is optimized for particular tasks and environments. Mainframe computers are a cornerstone for large organizations, especially when it comes to handling highly critical applications. Think of tasks like bulk data processing or managing enterprise resource planning systems, which are essential for keeping the business running smoothly. What's impressive about most mainframes is their ability to host multiple operating systems at once. This means they can run several virtual machines simultaneously, effectively acting like multiple servers in one machine. In fact, they can often replace several smaller servers, making them a powerful and efficient solution for big organizations. Throughout this presentation, we've seen how different computing solutions meet various organizational needs, and mainframes are a prime example of high-capacity, reliable infrastructure supporting critical business functions. Now, let's talk about mini-computers. In terms of size and processing power, mini-computers are actually positioned between mainframes and microcomputers. Think of them as the middle ground in the evolution of computing technology. They're also called mid-range systems or workstations, which highlights their role as versatile and powerful enough for many business applications, but still smaller and more affordable than the large mainframes. The term mini-computer started to be widely used back in the 1960s, when these systems were recognized as relatively smaller, third-generation computers. This development was a significant step because it made computing more accessible to a broader range of users and industries, helping to bridge the gap between large enterprise systems and personal computers. Understanding mini-computers helps us see how computing technology has continuously evolved to become more accessible and tailored to different needs. Let's talk about servers. Think of servers as powerful computers specifically designed to provide services to client machines within a network. Essentially, they run programs that respond to client requests and manage resources like memory and processing time to ensure everything runs smoothly. You'll notice that servers are usually quite large, equipped with high-performance processors and multiple hard drives, which helps them handle large volumes of data and multiple requests simultaneously. An important aspect of servers is their fail-safe design. They're built to resist crashes and continue operating reliably, which is critical for maintaining overall network stability. Connecting this to our broader theme, servers are the backbone of network infrastructure. They ensure that all parts of the system communicate effectively and reliably. Supercomputers are truly remarkable when it comes to handling highly calculation-intensive tasks. They are specifically designed to perform complex computations that would take regular computers an impractical amount of time. For example, fields like quantum physics, mechanics, weather forecasting, and molecular theory rely heavily on supercomputers because of their immense processing power. One of their key strengths is their ability of parallel processing, meaning they can perform many calculations simultaneously, significantly speeding up research and problem-solving. Additionally, their well-designed memory hierarchy allows for efficient data management, which is crucial for large-scale computations. Overall, supercomputers play a vital role in advancing scientific understanding and tackling problems that require enormous processing capabilities, aligning perfectly with our theme of high-performance computing. Let's talk about microcomputers. A microcomputer is essentially a computer that uses a microprocessor as its core. These machines are much smaller in size compared to mainframes, making them more accessible and practical for everyday use. When you add a keyboard and a mouse, these microcomputers are often called personal computers, or PCs. They are designed to fit comfortably on desks or tables, which makes them ideal for individual users. Because of their size and ease of use, microcomputers are perfect for single-user tasks, whether it's working on documents, browsing the internet, or managing personal data. They really represent a significant step in making computing power available to more people in a convenient, user-friendly way. This ties into our overall theme of how technology has evolved to be more accessible and tailored to individual needs. Let's talk about microcomputers, starting with desktop computers. A desktop is designed to stay in one place, making it ideal for a fixed location like an office or a home. One of the advantages is that the spare parts for desktops are pretty easy to find and generally cost less, which makes maintenance and upgrades more affordable. Unlike laptops, power consumption isn't a major concern for desktops, so they often use more energy. This is actually a benefit because it allows for better performance and durability. Desktops are really popular for everyday use, whether at work or at home, because they tend to be more powerful and customizable. Overall, they fit well into the bigger picture of computing devices, providing a reliable and accessible option for many users. Let's talk about microcomputers, starting with laptops. Similar in operation to desktop computers, laptops are essentially miniaturized versions designed specifically for mobile use. They pack the same functionality but are optimized for portability, making it easy to work or browse anywhere. Laptops run on a single battery, which allows for wireless operation, or they can be plugged into an external power adapter. The charger not only powers the device, but also charges the built-in batteries, ensuring that your laptop is ready to go when you need it. This mobility is a key advantage, connecting to our overall theme of versatile and convenient computing options. Whether for work, study, or leisure, laptops offer a flexible solution without sacrificing the power and features of larger desktop systems. Now, let's take a closer look at the different types of personal computers. When we talk about personal computers, or PCs, we're referring to machines designed for individual use, and there are several types to consider. The most common ones are desktops, laptops, and tablets. Desktops are typically larger and stay in one place, offering powerful performance and expandability. Laptops, on the other hand, are portable, lightweight, and convenient for working on the go. Tablets are even more portable, combining touchscreens with the ability to run many applications, making them perfect for quick tasks and media consumption. Understanding these types helps us see how computers are tailored to fit various needs and lifestyles, which is a key part of appreciating how technology integrates into our daily lives. Let's talk about netbooks. They fall into the laptop category, but they are generally smaller and more affordable. When they first came onto the market, they were quite popular for their portability and low cost. However, they had fewer features and less capacity compared to regular laptops. This made them suitable for basic tasks like web browsing and email, but not for more demanding applications. Understanding netbooks helps us see how technology evolved to offer more accessible computing options, balancing size, cost, and functionality. So let's talk about PDAs, or personal digital assistants. These are essentially handheld computers, and they're often called palmtops because of their compact size. They usually feature a touchscreen, which makes navigation and input quite intuitive. Inside, they have a memory card slot, allowing users to store a variety of data easily. But what's really interesting is how versatile these devices are. They can function as portable audio players, so you can listen to music on the go. They also serve as web browsers, letting you access the internet from almost anywhere. And of course, many PDAs can act as smartphones, combining communication and multimedia functions in one device. Most importantly, many of these devices can connect to the internet wirelessly through Bluetooth or Wi-Fi. This connectivity capability is a key point because it shows how PDAs have helped bridge the gap between mobile devices and internet access, which is a central theme in the evolution of technology and communication. Overall, PDAs exemplify how portable, multifunctional devices have become essential tools in our digital lives. Let's talk about tablet computers. These are portable, mobile devices that are incredibly handy for a wide range of tasks. What makes them so convenient is their touch screen technology, which allows us to interact with them directly through taps and swipes. You'll often find that tablets come with an on-screen keyboard for typing, but many also support the use of a stylus or a digital pen, which is great for drawing or precise input. A key point to remember is that Apple's iPad really revolutionized the tablet market, setting the standard for what tablets could do and how they could be used. It's a perfect example of how innovation can redefine an entire product category. Overall, tablets are an essential part of modern technology, blending portability with powerful features, fitting seamlessly into our daily lives and work routines. Wearable computers are a fascinating area of technology. These are devices that you can actually wear on your body, like smartwatches or fitness trackers. They're designed to be portable and convenient, allowing continuous data collection without disrupting daily activities. One of the key uses of wearable computers is in behavior modeling. They help us understand how people act in different situations over time. This is especially useful for tailoring personalized experiences or interventions. Another important application is in human health. Wearables can monitor vital signs, physical activity, sleep patterns, and more, providing valuable insights for medical research and personal wellness. Throughout this presentation, we've seen how integrating wearable technology aligns with the broader theme of making computing more seamless and human-centered. These devices exemplify how technology can be both functional and unobtrusive, enhancing our understanding of human behavior and health in real-world settings. Let's talk about computer systems, devices, and peripherals. These are the essential components that make up the technology we use every day. When we refer to computer systems, we're talking about the main hardware, including the central processing unit or CPU, which is like the brain of the computer, along with memory and storage. Devices are the tools that help us interact with the system, such as keyboards, mice, or touchscreens. Peripherals are external devices that expand the computer's capabilities, like printers, scanners, or external drives. These components work together seamlessly to perform a wide range of tasks, from simple calculations to complex data processing. Understanding how they connect and communicate is key to grasping how computers function as a whole. Remember, the efficiency and usability of a computer largely depend on the right combination of these systems, devices, and peripherals working in harmony. This connection highlights the importance of both internal hardware and external accessories in creating a complete computing experience. Let's take a closer look at computer systems, devices, and peripherals. These are the essential components that work together to make our technology function smoothly. When we talk about computer systems, we're referring to the entire setup, everything from the central processing unit to the operating system that manages all the hardware and software. Devices are the hardware components that perform specific functions, like the CPU, memory, or storage drives. Peripherals, on the other hand, are external devices that enhance or extend the capabilities of the main system, such as keyboards, mice, printers, and external drives. Understanding how these components interact is key to grasping how computers operate efficiently. The system's core processes rely heavily on the internal devices, while peripherals allow us to input data or receive output easily. This interconnectedness is vital because it highlights the importance of design and compatibility in building effective computer setups. As we move forward in this presentation, keep in mind that the seamless integration of systems, devices, and peripherals is what ultimately powers the modern digital world we rely on every day. So, what is an operating system? Well, it's the most important program that runs on a computer. Think of it as the backbone that keeps everything functioning smoothly. It performs the basic tasks we often take for granted, like recognizing input from the keyboard. So when you type, the OS makes sure your commands are understood. It also sends output to the display screen so you see what's happening. The OS keeps track of files and directories stored on the disk, organizing everything so you can find your documents easily. It also controls peripheral devices, such as disk drives and printers, making sure they work seamlessly with the system. Another crucial role of the operating system is security. It's responsible for ensuring that unauthorized users can't access the system, protecting your data and maintaining privacy. All these functions highlight how central the OS is to making our computers user-friendly, efficient, and secure, connecting all the hardware and software components into a cohesive system. Now, let's talk about the types of operating systems, starting with multi-user systems. These are designed to let two or more users run programs simultaneously. It's a way to maximize resource sharing and efficiency. Some advanced multi-user operating systems can support hundreds or even thousands of users working at the same time. This is especially important in environments like large organizations or data centers, where many users need access to the same resources without interfering with each other. For example, Linux, Unix, and Windows 2000 are all well-known multi-user operating systems. They manage multiple user sessions smoothly, ensuring each user has their own workspace while sharing the system's resources effectively. Understanding multi-user capabilities is crucial because it highlights how modern operating systems are designed to support collaboration and productivity on a large scale, which ties back to our overall theme of how these systems serve diverse user needs efficiently. Now, let's talk about the types of operating systems, focusing on multiprocessing. Multiprocessing is a key concept because it supports running a program on more than one CPU. This means that the system can handle multiple tasks simultaneously, greatly improving performance and efficiency. Think of it as having multiple brains working together to get things done faster. Popular examples of operating systems that support multiprocessing include Linux, Unix, and Windows 2000. These systems are designed to manage multiple processors effectively, ensuring that resources are allocated properly and that tasks are distributed efficiently. Understanding multiprocessing is important because it highlights how modern operating systems maximize hardware capabilities to provide better performance and multitasking. This is a crucial aspect of how operating systems support complex, resource-intensive applications today. Now, let's talk about the different types of operating systems, starting with multitasking. Multitasking is a key feature because it allows more than one program to run at the same time. This means you can, for example, have a web browser open while running a word processor or listening to music, all at once. It's what makes modern computing so efficient and user-friendly. Some common examples of operating systems that support multitasking include Unix, Windows 7, and Windows Multipoint. These systems are designed to manage multiple programs seamlessly, ensuring that each gets the resources it needs to function properly. This capability is essential for a smooth, productive user experience and is a fundamental aspect of modern operating systems. Let's talk about multi-threading now, which is a key type of operating system. Multi-threading allows different parts of a single program to run at the same time or concurrently. This means that a program can perform multiple tasks simultaneously, improving efficiency and responsiveness. For example, in a web browser, one thread might handle user input while another loads a web page in the background. Some common operating systems that support multi-threading include Linux, Unix, Windows 2000, and Windows 7. Recognizing these examples helps us see how widespread and essential multi-threading is across different platforms. Overall, understanding multi-threading is crucial because it reflects how modern operating systems maximize performance by managing multiple operations at once. Now, let's take a look at the different types of operating systems, starting with real-time systems. These are designed to respond instantly to input, which is crucial in applications where timing is everything. For example, in embedded systems or industrial controls, a quick response can be the difference between success and failure. It's important to note that most general-purpose operating systems, like DOS and Unix, are not real-time. They are built for flexibility and multitasking, rather than guaranteeing immediate responses. Understanding these distinctions helps us see how different OS types are tailored for specific needs, with real-time systems prioritizing speed and responsiveness above all else. Let's take a quick look at the evolution of Microsoft operating systems over the years. Starting with Windows 1 in 1985, this was Microsoft's first attempt at a graphical user interface, marking the beginning of a new era in personal computing. Moving forward, Windows 2 came out in 1987, building on the original with improved graphics and performance. Then, in 1990 and 1992, Windows 3.x made a significant impact by popularizing the Windows environment among a broader audience. In 1995, Windows 95 was a major milestone, introducing the Start menu and better hardware support, which really helped Windows become the dominant OS. The year 2000 saw the release of Windows 2000 and Windows ME, catering to both business and home users with new features and stability improvements. Windows XP, launched in 2001, was incredibly popular for its user-friendly interface and reliability, remaining a favorite for many years. Then, in 2006, Windows Vista was introduced, although it faced some criticism for performance issues. After that, Windows 7 came in 2009, offering a more polished and efficient experience. In 2012, Windows 8 aimed to unify the experience across devices with a new start screen, though it was a bit polarizing. The subsequent update, Windows 8.1 in 2013, addressed some of those concerns and improved usability. Moving ahead, Windows 10 was released in 2015, embracing the idea of a universal platform, and in 2016, the anniversary update further enhanced its features. Finally, Windows 10 continues to evolve as the mainstay of Microsoft's OS offerings, reflecting the ongoing importance of adaptability and innovation in the Windows ecosystem. This timeline really highlights how Microsoft has continuously adapted to changing technology landscapes and user needs over the decades. Now, let's talk about the importance of direction in this context. When we refer to direction, we're really focusing on the overall guidance and strategic path that we choose to follow. It's about setting a clear course so that everyone involved understands the goals and the way to achieve them. This helps ensure alignment across teams and departments, making our efforts more cohesive and effective. Direction isn't just about deciding what to do. It's about communicating that vision clearly and confidently. It connects directly to our broader theme of leadership and strategic planning. Without a solid sense of direction, even the best ideas can falter, so it's crucial to get this right. In essence, having a strong direction provides us with focus, motivation, and a sense of purpose, guiding us through challenges and helping us stay on track to meet our objectives. Now, let's go through the directions on this slide. The task is to identify the type of operating system being described in each sentence and write the answer on a quarter sheet of paper. First, number 1 says, allows more than one program to run concurrently. This points to a multitasking operating system, which can handle multiple programs at the same time, making our work more efficient. Number 5 states, supports running a program on more than one CPU. That describes a multiprocessing operating system, which can utilize multiple CPUs to boost performance. Next, number 2 mentions, responds to input instantly. This is characteristic of a real-time operating system, which is designed to process data immediately and is often used in critical systems. Number 9 asks, what is the most important program that runs on a computer? Well, that's the operating system itself. It's the core software that manages all hardware and software resources. Moving on, number 6 talks about the latest version of Microsoft Office operating system. That's a bit tricky because Microsoft Office is software, but perhaps this refers to an operating system compatible with Office, like Windows. Number 7 asks, what is the logo of the Linux operating system? Think of that penguin, a symbol most associated with Linux. Number 10 asks about other operating systems aside from Linux and Microsoft OS. That includes systems like macOS, Unix, or even Android, broadening our understanding of different platforms. Number 4 states, allows different parts of a single program to run concurrently. This refers to a multitasking or multi-threaded system, where different parts of a program can execute simultaneously for better performance. Number 8 asks, the successor to Windows 7. That's Windows 8, which introduced new features and a different interface. So, by connecting these descriptions to the key concepts of operating systems, whether it's multitasking, multiprocessing, real-time capabilities, or specific platforms, we see how diverse and vital these systems are in enabling our computers to function smoothly. This understanding helps us appreciate the different types of operating systems and their roles in our daily tech experiences.